So you will find this for a refueling. What you will find? You will find this part. What is this wire? Actually, this wire, what is the purpose of this wire? This wire is used for earthing. Earthing means if this pipe will get a charge, this earthing wire will remove the charge out. So when this earthing wire will remove the charge out, so it will reduce the chance that the air might get, or the pipe might get a charge. So as it reduce the charge or reduce the charge from the material, so it will not produce a spark and the petrol tank will not catch a fire. So earthing is done for both. Earthing is done for the petrol tank as well, and it is done for this pipe as well. So if the petrol tank is getting a charge, like example, a negative charge, so this negative charge will flow out through the metal wire. If earthing is not used, then it is dangerous. It might catch, it reduce the chance that there is a buildup of a charge. So if earthing is not used, the charge might produce a spark, and that spark will cause a combustion or a burning of a fuel. So that will be dangerous. And you are learning here the dangers of static electricity. Is it clear? So for this, for the safety I just discussed, we use a lightning conductor. This already I discussed with you, that lightning conductor, the ground and all the objects are getting positive charge, but because of great lightning conductors are closer to the negative charge, so they are moving towards the ground, and it reduces the chance that a building is struck by a lightning or a flash. Then earthing. So what is the concept of earthing? Connecting a conductor to a charge object to remove the unwanted charge. We call that as earthing. So if I want to remove the unwanted charge, I don't want the object to be charged. So I connect the metal wire, and we call this metal wire as earthing. So example, if I bring a negative charge rod, lightning conductors are not used for every house. It's normally used for tall buildings, like 10-story building or more than that, use lightning conductor, because tall buildings likely chance that the lightning or a flash will hit, because tall buildings are closer to the charge air. That's why more likely the air, the negative charges will hit. So to reduce that effect, that's why they're using a lightning conductor. So example, if you have if you have you bring a negative charge rod near to an uncharged object, it creates a distribution of the charge. What we call this? Electrostatic friction or electrostatic induction? What we call this process when we create a distribution of the charge? So this is electrostatic induction. Now what we will do, we will connect an earthing wire now. Earthing wire means a metal wire which we want to remove the charge. So the moment when we connect an earthing wire, any metal wire is connected to the ground. So what happened? This negative charge is attracting the positive and repelling the negative charges. So these negative charges, now they have passage to go out. So these negative charges will go out. So as these negative charges will go out, what will be the most of the charge left on this metal? This metal wire, earthing wire, is also made up of conductor. So what is most of the charge left on the metal? As the negative charges are going out, so most of the charge which remain on the metal are positive. And same way, if I bring a positive charge rod, when I bring a positive charge rod, so what it create? It create a distribution of electrons towards one side and positive ions towards another. But keep in mind, positive ions are greater in size. So when I connect an earthing wire, the positive ions are there. Positive, why the positive? Because positive ions, due to their mass and size, cannot move easily. So these positive ions will attract the electrons from the metal or the ground, and these electrons will enter the metal. So as most of the electron enter the metal, so what will be the net charge? The net charge will be negative. So here what happened when we bring an, so positive ions cannot move easily. Why they cannot move easily? Because of their size and mass. Negative charges are simply electrons. So what happened when we bring a positive charge rod? It creates a distribution of the charges within the material. When we connect an earthing wire, so the moment we connect an earthing wire, one side will be negative, one side is negative, one is positive. And when we connect an earthing wire, majority of the electrons will come in. So there are positive charges, but there are most of them are negative. And this one, there are negative charges, but most of them are positive. So this is called when we want to remove unwanted charge from a material. So what we can do, we can connect an earthing wire, so which remove the unwanted charge from the material. If I want a permanent charge here, which I should remove first, a charge rod or the earthing? If I want this to be have permanent positive charge, which one I should remove first, the earthing wire or the charge rod? We should remove the earthing wire, that's correct. Because what happened? We should remove the earthing wire because what happened? For example, if you remove the charge rod, so if you remove this charge rod, so if this charge rod is removed, now you can see as the electrons which travel out initially, now these electrons will experience attraction and they will return back. So as these electrons will return back, then this material will not be charged. So whenever we want to make a permanently charged, what we should do? We should remove the earthing first, and then we should remove the charge rod. So first earthing wire, and then the second thing is charge rod. Same thing here. If you want to remove, so first we should remove earthing wire and then we remove the charge rod. Is it clear? No, it is not gaining electron from air. It is taking electron from the metal wire, the earthing wire. The second picture, it is taking electron from the earthing wire, not from air. It's a metal wire, so metal is having a free electron. That's why these electrons coming out, coming into. So in this case, electrons are moving in. When we bring a negative charge, the electrons will move out. Another example, if there were two metal spheres touching each other or in contact with each other, and I bring a positive charge rod. So what happened? If I bring a positive charge rod, like charges repel and unlike attract. So this side, majority of them will be negative, and this side, majority of them will be positive. And then what I will do, if I want to make them permanently, charged, so I will separate these two spheres from each other. So moment I separate from two spheres from each other, So what will be the charge on A? The charge on a majority, there are negative, but majority of them are positive, and there are positive, but majority of them are negative. So A and B will be charged. So when two metals are touching each other, we can bring a charge object. When I bring a charge object and I create a distribution of the charge, what we call this? We call that as induction. And when I separate them from each other, because the charges are not able to transfer back to their original position, so its metal sphere A will get a positive charge and sphere B will get a negative charge. Is this clear?
Again, sir, please.
You have two metal spheres originally uncharged, but if you bring a charged rod, it creates a distribution of the charge. Negative charges move towards one side and positive charges to other side. And if I separate the two spheres from each other, what happened? The sphere A will left mostly positive charge and sphere B is left mostly negative charge. So this is a charging by induction
All right.
for two metal spheres.